Okay, now we will continue our networking journey by moving up from layer 2 to layers 3 and 4 to see more protocols used to communicate and what attacks and defenses exist in those protocols. So as a quick reminder from last time, we talked about low-level network attackers, we talked about different types of attackers, and we talked about ARP and DHCP, which have similar vulnerabilities where someone broadcasts a request and the first answer is accepted, so an attacker can send a malicious answer that gets accepted. And then we talked about WPA, which is a handshake-based protocol, and we saw different attacks on the handshake, and we saw WPA Enterprise, which defends against those attacks. So today we move up from layer 2 to layers 3 and 4. We'll see one protocol at layer 3 that has to do with routing packets through the network, and then we'll see two choices of protocols at layer 4, depending on what properties you want at layer 4. So this is the plan. So we'll start at layer 3 by talking about a layer 3 protocol called BGP, stands for those words which I don't remember. So as a quick reminder of what's happening at layer 3, remember that layer 3 gives us global connectivity. It takes a lot of local networks, connects them all together using routers, which I think of as post offices, and that gives you a globally connected network where anybody can send a packet to anybody else in the world, which is pretty amazing. Now for this to work, everybody has to speak the same language. In other words, we all need to agree on the same protocol for sending packets across the world. Because we're all connected in a single global network, we all need to speak the same protocol, and that protocol is called IP, or Internet Protocol. And remember, one of the parts of IP is the fact that everyone has a unique IP address. IPv4 addresses look like this. IPv6 addresses, which are newer, look like this. And somewhere in this address, although you and I can't see it as humans, is information about where the host is located. So if you're a computer, you can somehow look at these numbers and deduce that this computer is off in Asia or Europe or Australia. That's something that these numbers encode, even though you and I as humans cannot understand what they mean. But somewhere in this number is where that computer is located. And if a computer disconnects and moves somewhere else, they would get a different IP address. So how does a router know where this IP address is located? How do you take this number and deduce where the computer is? Well, you do so using these subnets. And you can think of a subnet as a range of addresses that all start with the same bits. And everyone in the same subnet is located in the same geographic region or local network. So for example, if we took all of the addresses starting with 128.32 and the last two numbers can be anything, this could be an example of a subnet, and it might be the case that everybody in this subnet is located in the same city or in the same network. Or maybe it's the case that everybody connected to UC Berkeley's network has the same 24 bits at the start of all of their IP addresses, and this is how we group hosts together so that we know where they're located. So we're not going to cover the exacts of how these subnets work. Just know that the way that these numbers encode locations is by grouping people together into these subnets. It's kind of like how in the postal system, everyone in a certain region has the same zip code, and that's how you know they're all in the same place. Something kind of similar is happening here, although you don't have to know the specifics. And the other thing we should call out before we dive into the protocol is the fact that in an IP network, packets can take many hops across different routers on their way to the destination. So if you're a router, you might not be able to send this packet directly to its intended destination, but you can send the packet to one of your direct neighbors in the hopes of getting the packet closer to its destination. And if all of the routers are forwarding packets to get them closer and closer to their destination, then it hopefully should be the case that everyone gets their packets to the destination in the end. So one question we should ask now is, how do those routers know where to send packets on the network? If you're a router, and remember, as a router or a post office, your entire job is to receive packets and forward them closer to their destination. How do you know where to send packets? If you get a packet that's for a specific IP address, do you send it that way? Do you send it that way? Do you send it this way? It's not clear where to send it, and that's a problem we have to solve called routing. So some possible solutions: if you are directly connected to the destination, for example, the destination is in your local network, and that's something you might notice because you share the same subnet as the destination. That could be a clue that the computer is in your local network. It's like the computer having the same zip code as you. Well, then what you could do is just use ARP to get a destination MAC address. So translate the IP address to a MAC address and send the packet directly to the destination. So this is what you might do if you were directly connected to the destination. What if you're not directly connected to the destination? Well, one thing you could do if you're the original sender is you can send the packet to your router. And remember, in DHCP, when you first connected to the internet, the DHCP server told you where the router is, and it said, if you have packets for the rest of the internet, send them to this gateway router. So if you're a computer sending a packet and you don't know where it's supposed to go, and it's not in the local network, you can send the packet to the router, and once it gets to the router has to forward the packet to other routers, and they all have to work together to deliver your packet closer to the destination. So these are the two possible cases. If you create a packet for the first time, if your destination is local, just send it yourself. If the destination is not local, give it to the gateway router, and they will coordinate with other routers to forward the packet closer.